This is Teacher Vanji. I know you are having a hard time learning by yourself. Your parents are struggling too as they guide and help you. Don't worry, I am here to help you through my weekly tutorial videos that will teach you different topics in mathematics. Just like, subscribe, and hit the bell button so you'll be able to watch my weekly tutorial videos. Enjoy learning! Have fun! See ya! Hi, we are now at week 2 of our lesson. And for this week, we are going to have this topic, multiplication of simple fractions and mixed fractions. In multiplication of simple fractions, we have 3 rules. Number 1, multiply the numerators. Number 2, multiply the denominators. And the third, or number 3, is right answer in lowest term. Always remember these 3 rules that we are going to use as we multiply simple fractions. Now, I will show you how to multiply simple fractions. Remember, when we say simple fractions, they are just composed of numerators and denominators. So what is the first rule? It says to multiply the numerators. So in our example, 1/2 times 3/4, the numerators are 1 and 3. So we're going to multiply them. 1 times 3 equals 3. Then we have the next rule, which is multiply the denominators. In our examples, the denominators are 2 and 4. That's why we're going to multiply them. 2 times 4 equals 8. So 1/2 times 3/4 equals 3/8. And what do you notice about 3/8? 3/8 is already in its lowest term. So we don't need to follow rule number 3, which is to reduce it in its lowest term because it's already in its lowest term. See, multiplying simple fraction is very easy. Let's have another example. This time we have 2/4 times 4/8. Again, multiply the numerators. So the numerators are 2 and 4. So that will be 2 times 4 equals 8. And then the denominators are 4 and 8. So we will multiply it. 4 times 8 equals 32. So 2/4 times 4/8 equals 8 over 32. And 8 over 32 is not yet in lowest term, so we have to reduce it. What do you think is the greatest common factor or the number that we can use to divide the numerator 8 and the denominator 32? You're correct. The GCF is 8. So 8 divided by 8 equals 1. And 32 divided by 8 equals 4. So, 8 over 32 when reduced to lowest term is 1/4. 2/4 times 4/8 equals 1/4. And that is the final answer. Can you now multiply simple fractions? Yes, that's correct because it's very easy to do it. We are now at the next topic, which is multiplication of mixed fractions. Here are the rules. Rule number 1, change mixed fraction to improper fraction. Rule number 2, follow multiplication of simple fractions. Rule number 3, write answer in lowest term. Let me show you how to do it. We have here 5 and 5/8 times 3 and 2/3 equals n. So rule number 1 says you have to change mixed fractions into improper fractions. Why is that so? That is because you will not be able to do the second rule, which is multiply numerators and denominators, if you will not change mixed numbers into improper fractions. So how are we going to change mixed fractions into improper fractions? You are going to multiply the denominator by the whole number. So since our denominator here is 8 and the whole number is 5, that's why it becomes 5 times 8 equals 40. And then after that, you're going to add the numerator 5. So that becomes 40 plus 5. And the answer is 45. Let's proceed to the next mixed number. Whole number times the denominator is 3 times 3, and that is 9. And then add the numerator 2, and that becomes 11. So 5 and 5/8 times 3 and 2/3 becomes 45 over 8 times 11 over 3. 45 is the answer when you multiply the denominator by the whole number and add the numerator. And that is also the same with 11. So, this become the improper fractions now. We can now proceed to rule number 2, which is to multiply the numerators and the denominators. So that will be 45 times 11. And the answer is 495. Now let's multiply the denominators. And that is 8 and 3. So 8 times 3 equals 24. So 45 over 8 times 11 over 3 equals 495 over 24. And what do you notice about the answer? Yes, that's correct. It's an improper fraction, so we have to reduce it. And how are we going to do that? Yes, by dividing the numerator by the denominator. So that will be 495 divided by 24, and the answer is 20, remainder 15. So how are we going to write the answer? The answer, which is 20, becomes the whole number, and the remainder 15 becomes the numerator, and just copy the denominator 24. 15 24 is not yet in lowest term, so we have to reduce it using, yes, greatest common factor. And what's the greatest common factor of 15 and 24? You're correct. The greatest common factor is 3. So 15 divided by 3 equals 5, and 24 divided by 3 equals 8. So 20 and 15, 24, when reduced to lowest term, becomes 20 and 5, 8. And that is the final answer. 5 and 5/8 times 3 and 2/3 equals 20 and 5/8. Let's have another example. This time, it's a mixed fraction and a whole number. So how are we going to do that? Again, multiply the whole number by the denominator. So that is 10 times 2 equals 20. And then add the numerator 8. And that becomes 20 plus 8 equals 28. So 2 and 8 tenths becomes 28 over 10 times 12 over 1. Did you notice anything about the whole number 12? Yes, that becomes 12 over 1 because in multiplication of fractions, when you multiply a simple fraction or even a mixed fraction like this one with a whole number, you have to show the whole number as a fraction using the denominator 1 so that it will be easy for you to multiply. So 1 represents as the denominator of any whole number. So we can now proceed to the next rule, which is numerator times numerator and denominator times denominator. So that's 28 times 12 equals 336 and 10 times 1 equals 10. So 28 tenths times 12 over 1 equals 336 over 10. And again, we have to reduce it to lowest term because it's an improper fraction. So we will divide 336 by 10. And the answer is 33, remainder 6. So 33 becomes the whole number and 6 becomes the numerator over the denominator 10. 6 tenths is not yet in lowest term, so once again, we have to reduce it using greatest common factor. And what's the greatest common factor? Correct, that is 2. So 6 divided by 2 equals 3, and 10 divided by 2 equals 5. So 33 and 6 tenths in lowest term is 33 and 3/5. And that is our final answer. So 2 and 8 tenths times 12 equals 33 and 3/5. So do you now know how to multiply mixed fractions? Very good. Our next topic is cancellation method. Cancellation method is very important in multiplication of fractions, and you will find out later why it is very important. Let me show you how to use the cancellation method by comparing it with the use of long method. Let us try this example, 5 7 times 14 15. I will use the long method in multiplying these fractions. So let us apply our knowledge of multiplying simple fractions. That will be numerators, numerator times numerator, and denominator times denominator. So that will be 5 times 14 over 7 times 15. So 5 times 14 equals 70 and 7 times 15 is 105 and their GCF is 35. So 70 over 105 in lowest term is 2/3. And that is the final answer using the long method. Now let us have the cancellation method using the same given 5 7 times 14 15. So in cancellation method, you are going to apply what we call cross cancellation. Why cross cancellation? Because you are going to focus your attention on the first fraction, the numerator of the first fraction and the denominator of the second fraction, as well as the denominator of the first fraction and the numerator of the second fraction. So, how is that? That means you will look at 5 and 15 as well as at 7 and 14. Cancellation method is really giving the simplest form or simplest term or lowest term of the fraction so that it will be easy to multiply. And since I talked about simplest form or lowest term, what does that mean? That means that you are going to look for greatest common factor of the numbers. So let us go back to 5 and 15. Is there a greatest common factor for 5 and 15? Yes, there is. And what is that? Yes, you're correct. So since we have a greatest common factor for 5 and 15, we are going to cancel them to show that we are giving their simplest form. And what is the greatest common factor of 5 and 15? That's 5. So 5 divided by 5 is 1, and 15 divided by 5 is 3. How about 7 and 14? Is there a greatest common factor for 7 and 14? Yes, there is. So let us cancel them. So the greatest common factor of 7 and 14 is 7. So 7 divided by 7 is 1 and 14 divided by 7 is 2. So what will happen now to the fractions? 5 sevenths will become 1 over 1 and 14 fifteenths will become 2 thirds. And we will now apply our knowledge of multiplication of numerators and denominator. So that will be 1 times 2 over 1 times 3. And the answer is 2 thirds, which is the same with the answer using long method. So you see, it is easier to use cancellation method because the numbers become smaller and it becomes easier to multiply them. But what's important is you know how to get their greatest common factor. Let's have a clearer example. This time, it's a mixed fraction times a simple fraction. We will apply our knowledge of changing mixed fraction into improper fraction. So 4 and 5 tenths times 12 over 15 will become 45 over 10 times 12 over 15. How did that happen? 45 is the answer when you multiply 10 by 4 and add 5. 10 times 4 is 40 plus 5 is 45. So look at this now. Once again, we're going to apply cross cancellation. So look at 45 and 15 as well as 10 and 12. Is there a greatest common factor for 45 and 15? Yes, there is. So we will cancel them. And what is that greatest common factor? You're correct. That is 5. So 45 divided by, again, what I mean is the greatest common factor of 45 and 15 is 15. So 45 divided by 15 is 3 and 15 divided by 15 is 1. How about 10 and 12? Is there a greatest common factor for 10 and 12? You're correct. So we can cancel them because there's a greatest common factor, and that is 2. So 12 divided by 2 is 6, and 10 divided by 2 is 5. So 45 over 10 times 12 over 15 will become 3/5 times 6 over 1. And let us multiply. 3 times 6 equals 18 and 5 times 1 equals 5. 18 over 5 is not yet in lowest term. Actually, it's an improper fraction. So we are going to reduce it to its lowest term by dividing 18 by 5. So 18 divided by 5, the answer is 3 and the remainder is 3. So when we write the answer, we're going to write the answer as the whole number and the remainder as the numerator. So 18 over 5 is 3 and 3/5. And that is the answer. So do you now know how to use cancellation method in multiplying fractions? Yes, multiplying fraction is easy when you know how to use cancellation method. But remember, you cannot always cancel fractions. You can only cancel them if there is a greatest common factor between the numbers. There is a possibility that you cannot apply cancellation method, so you will apply the usual way of multiplying fractions, which is numerator times numerator and denominator times denominator. Use cancellation method only if it is possible. Okay? Last topic for this week is solving routine or non-routine problems involving multiplication with or without addition or subtraction of simple and mixed fractions. So the first thing to do is to identify the difference between routine or non-routine problems. When we say routine problems, they are problems that requires only one operation or sometimes even two operations. But what makes it routine is that there is only one solution to solve the problem, while non-routine problems are problems that require two or sometimes three operations to solve. And there is no single solution to the problem. There can be two, there can be three solutions, but even though there are many ways of solving the problem, the answer still arrives at one answer, or the solutions arrive at one answer, even though there are different ways of solving for the answer. Since our topic for this week is multiplication, that's why the problems involve multiplication. And there will be a possibility that aside from multiplication, especially in the case of non-routine problems, multiplication will be with addition or subtraction, or sometimes both in the problem. Let's try to solve the problem below. Dino repaired two tricycles in 2 and 1/4 hours. He spent 1/3 of the time greasing the wheels. How many hours did it take him to grease the wheels? As what I've said in week 1, the first thing to focus on is the question. So the question is, how many hours did it take him to grease the wheels? So what is the problem asking for? Yes, it is asking for the number of hours it took Dino to grease the wheels. So the next thing to do is to look for the numbers that you can use to solve the problem. And what are those numbers? In this problem, those important numbers are 2 and 1/4, which represents the hours, and 1/3, which represents the time greasing the wheels. And the next thing to do is to identify the operation to be used. What is the operation to be used in this problem? Since we are looking for the number of hours it took Dino to grease the wheels, given the 2 and 1/4 hours and 1/3 of the time. Yes, you're correct. The operation to be used is multiplication. And what is the number sentence? Number sentence is n equals 1/3 times 2 and 1/4. So we are going to apply here our knowledge of changing mixed fraction into improper fraction. So this will become 1/3 times 9/4. Where did 9/4 come from? Once again, it came from 4 times 2 equals 8 plus 1 equals 9. And then you can apply your knowledge of cancellation. So what are the numbers that we can cancel here? Can we cancel 1 and 4? No. How about 3 and 9? Yes, we can cancel 3 and 9 because there is a greatest common factor between them. And what is that greatest common factor? You're correct. That is 3. So cancel 3 and 9 and divide them by 3. So 3 divided by 3 is 1 and 9 divided by 3 is 3. So 1/3 times 9/4 will become 1/1 times 3/4 or 3/4. And then we're going to multiply. The answer is 3/4 R. 3/4 R is the number of R it took Dino to grease the wheels. Now the question is, what do you think is this problem? Is it routine or non-routine? You're correct. This is a routine problem. Let's try to solve another problem. There were 90 children at the birthday party. If 3/5 of them were boys, how many were girls? So what's the question? How many were girls? So what is the problem asking for? It's asking for the number of girls. But look, the given are the number of children, which is 90, and the fractional part that represents the boys, which is 3/5. So, in this case, what do you think are we going to do? Since 90 represent the total number of children, and the given is the fractional part that represents the number of boys, we are going to have this number sentence. N equals 90 minus, open parenthesis, 3/5 times 90, close parenthesis. Why is the number sentence like this? As I've said, 90 represent the total number of children, which include the boys and the girls. Now, why are we going to get 3/5 of 90? We are going to get 3/5 of 90 in order to find out how many are the boys. And after getting the number of boys, we're going to subtract them from the number of children in order to get the number of the girls. Do you understand now why this is the number sentence? Now let's continue. So that will be 90 minus, open parenthesis, 3/5 times 90 over 1, close parenthesis. I put 1 as the denominator of 90, so it will be easy for you to multiply. Let's continue. We will cancel 5 and 90 because there is a greatest common factor between them. And what is that greatest common factor? You're correct, that is 5. So 5 divided by 5 is 1 and 90 divided by 5 is 18. Why did I not cancel 3 and 1? Because there is no greatest common factor between them. So we will not cancel them. And then let's continue. So this will become 90 minus 3 over 1 times 18 over 1. And the next will be 3 over 1 times 18 over 1 will become 54 over 1. And then, since there is no fraction with 1 as the denominator, automatically 54 over 1 will become 54. So now we can subtract 54 from 90, or 90 minus 54 equals 36 girls. So if there are 54 boys, there are 36 girls for a total of 90 children. So what does that mean? 3/5, which represents the boys, is equals to 54. And the number of girls is 36. Okay, do you know that there is another way of solving this problem? Let me show you. Let's use a different solution. The first solution that we use is using the number sentence n equals 90 minus, open parenthesis, 3/5 times 90, close parenthesis, where the answer is 36 girls. The other solution that we may use is this. N equals 2/5 times 90. Now, where did 2/5 come from? 3/5 is already given, but 2/5 is not given. So how did I get 2/5? You see, 5 over 5 equals 5 divided by 5, which is equal to 1. Therefore, 5/5 is a whole number. A whole number that represents 1 or a whole. Now, any fraction where numerator is the same as the denominator is a whole number. If 3 out of 5 or 3/5 are boys, therefore 2/5 are girls. Where did that come from? 3/5 came from 5 over 5, which is equivalent to 1 whole. And then since 5 over 5 minus 3 over 5 equals 2 over 5 or 2/5. So if 3/5 are the boys, therefore 2/5 are the girls. If 3/5 of 90 are boys, therefore 2/5 are girls. So that is the reason why this number sentence came to be. 2/5 represents the girls, which we will get. What is 2/5 of 90? So 2/5 times 90 over 1. And then, can we use cancellation method? Yes, we can cancel 5 and 90 divided by 5. So 5 divided by 5 is 1, 90 divided by 5 is 18. So 2/5 times 90 over 1 will become 2 over 1 times 18 over 1. And then the answer is 36 over 1 or simply 36 girls. So you see, the answers are the same but with different solution. The question is, what kind of problem is this? You're correct. This is a non-routine problem because it has more than one solution to arrive at the answer. Whatever solution you did, provided that the answer is the same, your answer as well as your solution is also correct. Let's have another problem. In Sir Set's art class, there are 12 boys and 13 girls. If 4 and 21 25th cartulinas make one mask, how many cartulinas are needed to make masks for the whole class? So what is the question? How many cartulinas are needed to make masks for the whole class? So it's looking for the number of cartulinas needed for the whole class. And what are the numbers to be used? Of course, they are 12 representing the boys, 13 representing the girls, and 4 and 21 25th representing the number of cartulina that make one mask. So what do you think are the operations we are going to use? You're correct. We're going to use addition and multiplication. So here's the number sentence. N equals, open parenthesis, 12 plus 13, close parenthesis, times 4 and 21 over 25th. Now, did you notice the open and close parenthesis? We used that also in the previous problem. If numbers are inside open and close parentheses, it indicates that you have to perform the operation first before the next operation. So in this case, since 12 and 13 are inside the parentheses, it means you are going to perform addition first before you multiply. So let's do that. 12 plus 13 is 25 times 4 and 21 over 25. So we are going to change 4 and 21 25 into improper fractions, so that becomes 121 over 25, and we put 1 as the denominator of 25. If you notice, there is cancel already on 25 and 25 because we can cancel them using cancellation method using what number? Yes, 25 itself. So 25 divided by 25 is 1, and 25 divided by 25 is 1. So we are going to have now 121 over 1, or 121 cartulinas. So the whole class needs 121 cartulinas for the masks for the boys and the girls. Now, is there another solution for this problem? You're correct. This is the only solution that I can think of, because if you are going to multiply 12 by 4 and 21 25th and 13 by 4 and 21 25th, before you add them, it will be more complicated. So you see, in solving math problems, as much as possible, think of solution that will make your computation easier and faster. So this is what type of problem? This is a routine problem. So that ends our lesson for this week. I hope you learned a lot about multiplication of simple fractions and mixed fractions. Always remember, stay at home and be safe. See you next week for another tutorial videos in mathematics. Goodbye and have a week full of learning.